All right, guys, so to continue our work with both radians and degrees, we're going to keep adding on new vocabulary terms, but keep practicing with both types of measurement angles. So today we're going to be talking about coterminal angles, and in order to explain coterminal angles, I would like you to picture a spinner in a board game. So if I took a look at this coordinate plane, picture you have a spinner in a board game, and to use a little bit of trig terms here, this again is called the initial side. And let's say that I have a terminal side in the first quadrant, and I'm going to say this is 30 degrees. 30 degrees counterclockwise. So if you picture a spinner in a board game, this side could infinitely spin and could hypothetically land in the exact same location it started. But oddly enough, if my initial angle was 30 degrees and I spun one time around, it would no longer be 30 degrees because one time rotated is 360 degrees. Every time I spun in that board game, I would add 360 degrees on to my angle that I have here. So interesting. Coterminal angles have the same appearance. So like if I looked at this and I said, let me be more specific, I guess. Let me write down an exact example. Let's say that we start with 30 degrees, but instead we go around one time. So initially it was 30 degrees, but then because we went around again, we would add 360 degrees on. So this angle would now be 390 degrees. So 390 and 30 in terms of placement would have the exact same appearance, but it would have a different rotation or the amount of times it spins. This could keep going infinitely. If I started here and then went around twice and landed back where I started, technically what you're doing is taking 30 plus 360 plus another 360. And so you're ending, I believe, let me double check, I think you're ending with 700 something, 750 degrees. So again, same appearance, it would land here, but a very different rotation. And so that's really the definition of a coterminal angle. It has the same initial side, it has the same terminal side, it looks the same on a coordinate plane, but it has a different rotation. With that said, I would like to look at a couple of examples here. So let me erase this. If we looked and we wanted to determine four coterminal angles, two positive and two negative based on this angle. Before we find the coterminal angles, I think it's still good practice to picture where negative 20 is on a coordinate plane. So I want to remind you from a previous video that if we start here at the initial side of 0 degrees, this is negative 90, this is negative 180, and this is negative 270 degrees. The reason I went clockwise because the angle was negative initially. So if I were to draw my angle, I'd draw my vertex, draw my initial side, and negative 20 degrees would be in the fourth quadrant, pretty close to the x-axis. So just as a brief drawing here, I'm just going to say that this would be considered, let me change to purple, this would be considered my angle of negative 20 degrees. Now, it's always good to picture it, but now what we want to do is find two positive and two negative angles that look the same as negative 20 degrees, but rotate around the circle in either direction. So what we really want to do is either add 360 onto this current angle or subtract 360 onto this current angle, because what we're really doing, at least I'll show you one time, is saying what if we rotated all the way around the circle and then landed back here? What angle would you currently get? So let's see. If I start with negative 20 degrees and I add 360 degrees to that, I would get 340 degrees. So that will be one of my positive angles. If I took the 340 that I just landed and I added another 360 degrees, I would land at 700 degrees. Let's go the other way. If I initially started with negative 20 degrees and then I went the other direction, 360, and I subtracted it, I would end up getting negative 380 degrees. Now that I'm at negative 380, if I subtract another 360, I would get negative 740 degrees. So all of these angles, these 4 and negative 20, would look exactly like this. All of them would have the same exact view, but the number of times it rotated changes your answer. Oddly enough, it works for 4 pi over 7 as well. Now, this we know is in radians because there is no unit. Because we have a fraction, though, we need to think again about common denominators. Kind of like here how I said 0, negative 90, negative 180, negative 270. We need to think the same way about doing this in radians. So we know that this side is 0, or eventually if you work your way around is 2 pi. We know that this side is really pi. So if I have a denominator of 7, what I like to do before I even start graphing it is say, then this side is really 0 pi over 7, because that's where I'm starting. And if I go around and stop here, that's technically pi, or 180 degrees. So if I want to represent an angle in terms of sevenths, I'm thinking that that would be 7 pi over 7, because if you think about it, 7 over 7 reduces and crosses out, so this would really just be pi. The reason I'm writing 7 pi over 7 is because everything is in terms of sevenths now. So let's think about this. To get from 0 to 7 is 7 units. So this is halfway between. So this would be 3.5 pi over 7. So we're going up 3.5. Now we went another 3.5. So we go another 3.5. So this would be 10.5 pi over 7. Now we have everything in terms of sevenths. So now it'll be easier to graph 4 pi over 7. Let me draw my vertex, my initial side. This is 3 pi over 7, and 4 pi over 7 is just a little bit beyond that. So I'd say that your angle looks something like this. This would be the rotation, and your angle would be right here, 4 pi over 7. So this is your rotation right there. Now that we have it graphed, again, it's good to say how can we find all the coterminal angles. We can do the same as the previous problem, but instead of adding 360, because we're in radians, we can add 2 pi. So what if I started with 4 pi over 7, and I added 2 pi, which is really the same as 360. So again, just like the previous video or previous videos, we need a common denominator. So I'd have to multiply this by 7 over 7. So we have 4 pi over 7 plus 14 pi over 7. So we'd get 18 pi over 7 for one of my positive angles. If then we wanted to continue with the positive angles, we would have to start with 18 pi over 7, because that's where we just landed. We would add another 2 pi to that. Again, this is really 2 pi over 1, so we'd multiply this by 7 over 7, 18 pi over 7, plus 14 pi over 7. 18 plus 14 is really 32, so 32 pi over 7 would be my next positive coterminal angle. Now, some of you might notice that 14 pi over 7 was used both times. If you come back up here, if you added another 3.5, that would be 14 pi over 7, which reduces to 2 pi, so it makes sense that it came up here. So instead of writing plus 2 pi each time, if you think about, if we want to find the negative angles, if we start again with 4 pi over 7, and we subtract, not 2 pi, but we know that ends up with a common denominator, getting 14 pi over 7. So we have 4 pi over 7 minus 14 pi over 7. So we have negative 10 pi over 7 for my first negative angle. So next I start with negative 10 pi over 7, subtract 2 pi, or 14 pi over 7. So I would get negative 24 pi over 7 for my second negative coterminal angle. So just like the degrees, if I graphed any of these 4, they would look exactly the same as the angle that I have on here. Okay, so with that said, these next 2 examples do have bigger numbers, but what I'd like you to do is pause the video. I would like you to think about for degrees, I would maybe label as 0, 90, 180, 270. Think about where 420 would be on your graph. Think about where negative pi over 3 would be on your graph, and you might want to consider writing these sides in terms of a common denominator. So I'm not going to worry about coterminal angles yet. I just want you to think about where would this angle be on your coordinate plane. So please pause the video and give that a try. All right, so to check back in with you guys, this first example with the degrees, my angle ended up being in the first quadrant, and here's why. If you label your coordinate plane with degrees going from 0 to 90 to 180 to 270, if you go back, this is really going to be 360 degrees because it's 90 more. So if I want to get to 420, some of you might have noticed that 420 is 60 degrees beyond 360. So if you start at your initial side, go all the way around the circle, you land at 360. We're not quite at 420 yet, so you go about 60 degrees above that. So this would be your angle going counterclockwise. So if I wanted to find my 4 coterminal angles, we could find 2 positive first. So you could take 420 degrees, you could add 360 degrees, and you would get 780 degrees. You could then say, okay, I am now at 780, so I could add another 360, and I would have 1,140 degrees. If you wanted to find 2 negative coterminal angles, you could again start at 420, and you could subtract 360 degrees, and so you could get 60 degrees in an answer. Now, be careful. This is another positive answer. We don't have a negative answer yet, so you have to keep going, which because 420 is so large, that's why this happened. So now if I take 60 degrees and I subtract 360 degrees from that, I would get negative 300 degrees. And then if I took negative 300 degrees and subtracted 360 degrees, I would get negative 660 degrees. So 60 is another positive answer. You could use 60 degrees instead of 1,140. It's up to you because, as you know, there's technically infinite answers here. Now, the good old Radians problem. This one was a little trickster, so let me explain what I did. In red, I said, if I want to graph this radian, I noticed that the denominator is in terms of 3. So I went over to the side with pi, and it's always a good basis, and I said, how could I write this side with just a pi in terms of thirds? Well, if I wrote negative 3 pi over 3, the 3's would cross out, so if you did not have a denominator of 3, this side would just be pi. So I knew that was good. So what I said then was that if I started at 0 and I'm going to 3, I'm going 3 units. So halfway between that is negative 1.5. So I'd go from 0, negative 1.5, negative 3, negative 4.5. But then notice I have to get to negative 11, so I have to keep going. So I switch to blue to show you my second way around. If you add 1.5 to this, you get negative 6, negative 7.5, negative 9, negative 10.5. So then I notice that we have negative 10.5 pi over 3, which will represent this axis. So negative 11 pi is probably just beyond this axis. And so this would be my angle. And that also kind of helps with the coterminal relationship. So please, if you notice you have a radian with a certain denominator, write everything in terms of that denominator. Now, if I want to find my angles, if I take negative 11 pi over 3 and I add 2 pi to help find those 2 positive and 2 negative, this is really 2 pi over 1. I need a common denominator of 3. So I'm taking negative 11 pi over 3 plus 6 pi over 3, which would get me negative 5 pi over 3. So there's one of my negative answers. Notice, 2 pi is equivalent to 6 pi over 3, so I'm going to be using this. If we take where we landed, negative 5 pi over 3 plus 6 pi over 3, I get 1 pi over 3. I can keep going. Pi over 3 plus 6 pi over 3 would get me 7 pi over 3. And if I want one more, let's see, if I want another negative angle, I could go back to negative 11 pi over 3, subtract 6 pi over 3, and get negative 17 pi over